Hello and welcome to Think Python, Chapter 3. Let's do some exercises. As usual, you can use this link to get to this page, which has links to all of the notebooks. But since we've already started working in Chapter 3, I'm going to go back to the notebook that we've already started, and we'll work on the exercises. If you didn't already run Xmode verbose, you should do that before working on the exercises. That way, if you make an error, you'll get a detailed traceback that contains all the information you need. As usual, I have some prompts here where I suggest questions that you could ask a virtual assistant in order to get help. Again, in the upper right-hand corner, there's a Gemini button that brings up the AI tool that's built into Colab. So, for example, if you want to ask a virtual assistant to write a function for you, we'll have it write a function called repeat that takes a string and an integer and prints the string the given number of times. So I'll copy that and paste it into Gemini. In general, Gemini does a pretty good job with questions like this. If you ask it to generate relatively short Python functions, they're usually correct, but you should remember that it does make mistakes. So anytime you use a chatbot or a virtual assistant to generate code, you'll want to bring that code in and, as it says here, use that code with caution. So I'll close that for now. And let's work on some of the exercises. I'm going to suggest that most of the time you at least attempt these exercises by yourself, and then ask for help if you need it. The first exercise says, write a function named printWrite that takes a string named text as a parameter and prints the string with enough leading spaces that the last letter of the string is in the 40th column of the display. Okay. The way the question is asked gives us a lot of the information that we need to get started. We know that the name of the function is printWrite and that it's going to take a string named text as a parameter. For my first draft of this program, I'm just going to print the text. And this is a way of developing programs that I recommend, which is to start with the simplest program that does something, almost anything, correctly, and then gradually add features as you go. So I'm going to define this function, and then in the notebook I've provided some code that you can use to test your function. And if I execute that, we'll see that it does work. It takes each of those strings and prints them. So that's a good start. The next step, if I want to put the last character of the string in the 40th column, I'm going to need to know the length of that string. So I'm going to use the length function to find the length of that string, and I'm going to save it in a variable I'll call n. And again, I'm going to define this function and run it just to make sure that everything is still working correctly, although so far it hasn't done anything different. I'm going to define another variable called space, which just contains a space character. That's going to make things a little bit easier to read, and the function is still working. Now, the number of empty spaces that I need before I print text is going to be 40 minus the length of that string. And again, I'm going to run the function, just make sure it's all still working. And now I should be able to finish off the function by printing my space character multiplied by n, so that's the number of spaces, followed by the text. And I'll use the concatenate operator here. I'm going to define that function and then run it. And it looks like it has printed Monty Python's Flying Circus with the right-hand side of each string lined up on the 40th column. So let's take a look at the second exercise. It says, write a function called triangle that takes a string and an integer and draws a pyramid with the given height made up using copies of the string. So I'm going to define a function called triangle, and it's going to take a string and an integer. And it's going to draw a pyramid with the given height. It seems like I'm going to want to use a for loop here. So for I in range n, print string. And again, I don't think this function is complete yet, but it does something. And when I run it, we'll see that it prints the right number of lines, but the lines themselves are not correct. Now, what happens if I multiply the string by I? That looks pretty good, although it might be off by 1. What happens if I make this I plus 1? That looks like what we're after. So again, I think this is a good strategy for writing programs, which is to start with something simple that works and gradually work toward what you're trying to create. We'll see that one more time with the next exercise, which says, write a function called rectangle that takes a string and 2 integers and draws a rectangle with the given width and height made up using copies of the string. So we'll define rectangle. It takes a string and a width and a height. We'll write a for loop for I in range height. And again, I'll start with something simple by just printing the string. Define that function and run it. That looks pretty good. The height is 4, and it drew 4 lines. Now the width I can do using multiplication. String times width should make width copies of that string. And if I run it, it makes a rectangle with the given width and the given height. For the next exercise, we're going to write functions that print the verses of 99 bottles of beer. If you're not familiar with the song, each verse goes 99 bottles of beer on the wall, 99 bottles of beer, take one down, pass it around, 98 bottles of beer on the wall. And then the second verse is the same, except that we replace 99 with 98, and then 97, so it's a very long song. To get started, I'm going to write a function that's called bottle line that prints one line of the song. It's going to take n, which is which verse we're currently on, and a suffix that it will print at the end of the line. And this will print n, followed by the string, bottles of beer, followed by whatever that suffix is that's provided when this function gets called. And I can call that function bottle line with 99 and the suffix on the wall. And I get 99 bottles of beer on the wall, which is the first line of the song. I'm going to copy that line and run it again with no suffix. When I run that, I get 99 bottles of beer, which is the second line of the song. For the third line of the song, I'll just write, take one down, pass it around. And now I get the first 3 lines. And finally, I'll repeat that first line at the end and get a complete verse. Now, I have 4 lines of code here that print a verse of a song. I can transform those lines of code into a function by adding a header, which is def bottle verse, that takes n as a parameter. And now to put these lines inside the function, I need to indent them. So I'll use the tab button. And now I have a function called bottle verse that prints one verse of the song. It's not quite correct yet, but I'm going to go ahead and define the function and then call it here. Now in this case, I got the 99th verse of the song, which is correct, but you'll notice that if I change the argument here to be 98, it doesn't work. I still get 99. And the reason is, inside this function, I take the parameter n, but then I ignore it, and I use 99 all the time. But if I replace 99 with n, each place where it occurs, and redefine this function, and then when I call it, I should get 98 bottles of beer on the wall. This is often a good way to write a function, which is to write some lines of code, and then get them working, and then put them inside a function. To finish it off, we can print the whole song by using this for loop. It uses a feature we haven't seen before, which is that it counts down instead of up. It starts at 99, it goes down to 0, and it, each time through the loop, decreases by 1. If I run this loop, we'll see that it prints all 99 verses of 99 bottles of beer on the wall. So, congratulations on finishing Chapter 3. I'll see you next time in Chapter 4.